Arguably, writing a program in parallel C using CUDA on a GPU is one of the easiest ways to develop a parallel application. It's not easy to develop a parallel application on a multi-core CPU because there's no support for it, there's no tools. This technology allows scaling from small computers to personal supercomputer platform that we're introducing today, all the way up to clusters with the same programming model. You can write programs using CUDA that run across the full scale. And this is made possible by this computing architecture that we've built into every GPU that we build. So whether you have a laptop, if you're running GeForce, if you're running Quadro Professional product, or if you're running with the Tesla computing product, you have the same GPU core, the highly parallel processing core, which is the foundation for the GPU computing. And on top of that, you have the ability to run graphics, of course, because that's our historic business, but also you have the ability to write programs in C. You will have the ability to write programs using the OpenCL API. We're developing tools for Fortran and C++. In the future, DirectX 11 compute will be supported on our hardware. So this GPU computing substrate, the CUDA architecture, supports all these different ways of writing programs. Another thing that's important to think about is the efficiency of the computing. If you are consuming enormous amounts of power, that's not a practical kind of approach. Using GPUs for high-performance computing is a green approach. It's much better, much lower power per performance, so better performance per watt. It's also much better performance per dollar and much higher overall peak performance. When you compare what you're able to do with conventional CPU-based computing to what you're able to achieve with heterogeneous parallel computing with a GPU and a CPU, the results are really phenomenal. And I think that I don't want to minimize the importance of faster, because faster is always great. But at a certain point, faster is also qualitatively different. If you are able to accelerate an application that used to take days, and you can run it in minutes or seconds, it goes from a slow plodding discovery process to an interactive exploration of the problem. It is a level of performance that 5 years ago was millions of euros or millions of dollars or millions of pounds worth of computing. And it's now affordable that everyone can have one. And it's a standard amount of power, no special wiring and refrigeration required in order to run this. Bringing teraflops to the desktops of millions of scientists will fundamentally change science. It will create enormous new opportunities for discovery.